Okay, can you guys see this okay?
Yep.
Yes.
Yes.
Okay, so I am co-founder and CEO of Hyperframe. We're a construction technology startup company, and we provide a prefabricated light gauge metal wall framing system for commercial buildings that snaps together on site with almost no skill and almost no tools at generally 5 times the speed of traditional light gauge metal wall framing. So these are generally for non-load bearing partition walls in commercial structures. And so I thought it would be fun to explain our product through the lens of a pilot project that we recently completed with DPR Construction. And this was actually Hyperframe's first medical project. This was an existing medical building in San Mateo, California, where the interior was completely gutted down to concrete and rebuilt from the inside. So, so I'll start out by telling you a little bit about the project and the impact Hyperframe had, and then I'll go back and explain how Hyperframe achieved those results and how our technology works. Does that sound good?
Sounds great.
Okay, so we're fortunate that DPR is one of Hyperframe's earliest customers. We started the business in early 2019 and spent several years in research and development. So we really started fulfilling large-scale projects for the first time about a year ago. And this medical building was not our largest, but it was our most complex, which will be interesting from a technology perspective. Prior to doing this medical project earlier this spring, DPR got their toes wet with us with a very small pilot in San Francisco. This was a very small office TI for one of their new offices that they were building for themselves. And then we graduated to a slightly larger, but still very small project in another one of their offices that they were building in Santa Clara, California. It was a little bit larger, but much more complex from a MEP coordination perspective. It was a bank of bathrooms that required significant coordination. And so those projects went so well that DPR proposed that we step up to an actual full-scale project. Like I said, this was a 4-story existing medical building in San Mateo where levels 3 and 4 were completely gutted down to concrete and would be rebuilt. And this was in total, looks like about 3,500 linear feet of wall. So this was DPR's largest project with us yet. And this being our first medical project, we were exposed to the complexity of the MEPF coordination in a medical building for the first time. Most of our projects before this were multifamily buildings, which from a coordination perspective are much easier and are much easier to prefabricate things for. So this is a much more difficult test of our technology. And the results that DPR achieved were a 3x production increase for light gauge metal framing installation. They achieved something on the order of 9 linear feet of wall framed per man hour. They estimate that they saved in excess of $100,000 on this project, which would have been roughly 30% of the total installed cost of the framing when you consider the combination of labor and materials. And since almost every wall stud snaps together from the ground without the need for scissor lifts or ladders, there was an 80 to 85% decrease in elevated work. And so this was a very successful project with one of our earliest customers that lays the groundwork for much larger projects yet. So we're really thankful to them. So now I want to go back and explain in more detail what Hyperframe is and how we achieve this. And the most important thing to understand is that Hyperframe is a full workflow of vertically integrated technologies that start in pre-construction and run through manufacturing and construction to achieve the types of results that I was talking about. And so in the pre-construction phase of the project, the first product that our customers use is a is a proprietary cloud-based BIM application called HyperBIM. And HyperBIM automatically generates the complete framing BIM for the project. It automatically frames around all of the MEP. It automatically flags all of the unbuildable and unmanufacturable conditions to generate a punch list of issues that can be resolved in coordination. And it automatically reconciles what I call the fairy tale BIM to a point cloud of the as-built structure, so that the model that is approved for manufacturing is going to be a one-to-one match for what is going to be installed in the field. And so that's about half of the engineering effort of the company goes into that software. Second, we have our own. I'm actually sitting in our very first factory outside Oakland, California, and Hyperframe has created several brand new manufacturing processes to prefabricate each stick of metal framing off the model and pre-fasten a snap connector to every connection point on every stick of framing, and then kit those elements by zone and ship and stock that product into the building. It has required a total rethinking of how metal framing manufacturing works. Once on site, a kit of framing is staged in its corresponding zone of the building when the product is stocked, and the installer works from the top of the kit to the bottom, meaning that the first part that they need is at the top and the last part they need is at the bottom. Every single piece is QR code labeled in the factory, and so the way it works is when a customer when the installer picks up the first piece off the top of the kit, they scan the QR code with a smartphone, and the smartphone will show them in 3D augmented reality where that piece fits in the building, and then they will snap it into place. And so it is the vertical integration of all of these technologies that achieves the kinds of results that I presented with the DPR project. So I'll dive into a little bit more detail on each one of these elements. This is a screenshot of what HyperBIM looks like. This is 100% cloud-based. So you just go to the Hyperframe website and log in, and all of the heavy lifting is done here. And so this reads in the architectural wall dimensions and door opening dimensions from a Revit file, but then after that, all of the clash detection and modeling and issue flagging is all done online, which means that it's incredibly fast. It means that you don't need a special computer to run it. You can run it on anything. You don't need a very expensive workstation to run it. You could have multiple users working on it concurrently, and it's always up to date. So this, I think, depending on the project and what the level of MEP coordination complexity is, reduces the amount of BIM effort down from man weeks or man months down into, I don't know, less than a week or potentially less than a day, depending on the project. It is almost a total automation of framing modeling.
Wow.
And so like the first thing you'll get with HyperBIM is that it gets you to a 100% complete model. But a lot of times, one of the problems with BIM in general is that the model won't match what you're actually building, because there are construction tolerances and everything, and you have issues between what is the ideal, what are the ideal conditions and what are the as-built conditions. And so on every single Hyperframe project, Hyperframe comes out and laser scans that floor of the building, and that point cloud goes back into HyperBIM, and HyperBIM will, in most cases, automatically reconcile the differences. And so, for example, if there's a concrete column that is slightly the wrong size, or is in slightly the wrong position, or is slightly out of plumb, and there are walls that are supposed to abut into it, we will shorten or extend those walls to meet. And this is part of our secret sauce, and it ensures that when our product shows up on site, it will click together the right way the first time. And so we try to eliminate as much field adjustment as possible. There's always some, but I would say well over 99% of our parts snap into place perfectly. Now, in our factory, we've had to, if half of the engineering effort of the company is in software engineering, the other half is in manufacturing engineering, and we have had to design all new automated manufacturing stations to quickly but accurately mass customize our product for each project that we serve, because every building has a different floor plan, every building has different deck heights, every building has, it's all different. Studs are in different positions, and so all of our manufacturing equipment reads data directly that comes directly from Hyperbim, and the snap connectors are automatically pre-fastened with either spot welds or rivets in the places that the BIM has dictated. And so this is just a picture of a self-piercing rivet station that installs snap connectors on the ends of door and window headers, as an example. But there's a whole factory of stuff that looks like this, and it does not. Most metal framing factories look like roll formers, and there's just lots and lots of roll formers. The Hyperframe factory is quite different, and it is the integration between the software and the manufacturing that enables a lot of what we do. Kitting is really important because in some ways we're delivering some of the largest jigsaw puzzles in the world to our customers, with all these unique parts that where many of them only fit in one spot. And so on every project, the floor plan will be divided into zones, and zones that are the right size for a kit of framing to be loaded on a truck and then delivered up the man lift and staged. So for example, this here's a floor plan of that medical building. It was divided into, it looks like, about 20 zones. And so when the building is stocked, the kit of framing gets dropped in the middle of each zone, so that when you're building a kit, the installers don't have to walk more than, let's say, 15 feet away from where the kit sits in the structure. We're all about maximizing efficiency. And then the last piece is that we have this augmented reality application that runs on a smartphone to help the installer understand where all the pieces go. And so we have this is like a GoPro wrist mount accessory that holds a phone, and you'll hold the phone camera over a QR code label on the framing element, and then it will light up green to say that it was scanned, and then the installer will see this arrow here. And so what the arrow means is you should turn your body in the direction of the arrow, and when you're facing the right way, the part that you're holding will be lit up in green in 3D where it fits, and then you either snap that piece into place yourself, or you hand that piece off to a partner who snaps it into place. And so the framing speed of Hyperframe really just depends on how quickly the installer can pick up the next piece from the kit and get it to the right spot. It is not dependent on how quickly you can use the tape measure or a screw gun or a chop saw. And so that's generally how the product works. I'd love to take any questions you might have. We're at a really exciting, and here, let me just take off my screen share here. We're at a really exciting inflection point in the company where now we have shipped about 50 miles of Hyperframe, if you were to lay it all out tip to tail. And we fulfilled 4 to 5 major buildings now, mostly in the Western United States, although we just did our first project in New York City. And now we need to graduate to we're fortunate that all of our existing customers would like to order more, and we have a huge order book from new ones. And so we need to graduate to a much larger factory that is also much more automated. And so we're actually winding down our prototype factory here in California. And we are literally, as I speak, packing up our equipment into large trucks to move to Columbus, Ohio, and our first very large-scale factory will be located there. And we'll be able to manufacture something on the scale of, if you were to think about it in terms of like a New York City tower, we'll be able to manufacture roughly one floor of a tower per day out of the new facility. And so we have a lot of work to do to get the facility up and running, and then we have a really exciting pipeline of projects to start delivering after that. And we're very interested in meeting new potential users. Thank you very much.
Awesome. Thanks, Ken. Is your background construction, or?
I grew up around residential construction my entire childhood. And I think if I had my way, I would have become like a luxury home builder. But I didn't do that. I went to college. I became a mechanical engineer. And shortly after college, I started my first company, which had nothing to do with construction, but I really loved the idea of starting a company. And so this is now my second company. And this is really what I would like to do for the rest of my life if I can, because I get to have a huge impact on the construction industry. I get to use my mechanical, and I get to use my engineering abilities, and I get to build a big business. So it's a lot of fun.
Awesome. So questions. Oh, there's Chuck.
Has a
there
question.
you go. Yeah. Hey, Ken. I had to take a phone call in the middle of it, so hopefully I'm not asking a dumb question. Is your goal to actually go and self-perform these the installation of the walls, or is it to be a supplier to the subcontractors in the industry?
It is to be a supplier to the framing installers, whether that's a drywall sub or a self-performed general contractor. We like to apply our efforts where we feel we have unique capability, and so engineering all those things is the unique capability we have. And the value of the product is that it is so easy that anybody can do it. One of the things I love to see is we had one project we did where there was a Ukrainian refugee who had never picked up a piece of metal framing in his life, and we trained him in half an hour in the morning, and by the end of the day, he was installing 5 times faster than a journeyman. And so we don't really provide any unique value if we were to go self-perform this. What we'd like to do is we'd like to scale up what we're doing, and I have a team full of engineers, and there's you'll trip over 10 problems on a construction site on just on your way in the door. So we'd like to go continue developing awesome new products.
Yeah. So my next question is about the BIM process. So we're a BIM service provider. We also do LiDAR scanning. So you mentioned both of those things, I think. So we model framing for framing subcontractors, the metal stud, just like you're installing. So my question is, what's the process, the coordination, the software process? We use Revit and the metal stud StructSoft, the metal stud framer, MWF. Yep. What's the input for your process?
Yes. Unfortunately, we found that the combination of Revit and StructSoft is incredibly hard to work with.
Okay.
And at best, even after extreme effort, you only get a model that's 90% good. And 90% good is it's good enough if you just need to supply a model to the GC just so that they have it, but it's not good enough to manufacture from. You really need something that's as close to 100% good as possible for manufacturing. And so we have a very lightweight Revit plugin, and the only purpose of the plugin is to extract the architectural wall data and send it to our server. So that way we don't have to deal with the huge Revit file sizes, because the wall data is just a small portion of the Revit file. And from there, our customers will they'll obtain the most up-to-date IFC files for the other trades and upload those into Hyperbim 2, and then Hyperframe will automatically clash against all those elements and deliver the lowest cost, highest quality model that is possible. And so behind the scenes, the software is generating 1,000 potential framing layouts for every wall. and then it grades it against the formula of what is a good wall. And so the wall that is the wall design that is surfaced to the user is mathematically the best possible wall design that can be had.
Is your business model to do all that engineering, BIM coordination yourself, or are you going to empower BIM service providers or even, you know, internal BIM teams at metal stud framing subcontractors to do it?
We would like to empower them to do it.
Nice.
So DPR is an example of a customer who is using the software themselves. There are a lot of drywall subs that don't have any BIM knowledge, and they're very scared by it. And so I think we're designing a tool that actually makes it significantly easier and means that you can means that these people can finally do BIM. And so, you know, we tend to hold their hand on the first project or two, but the goal is really to, whether it's a BIM service provider or the end customer, the goal is for others to do it. We, you know, it would just be impractical for us to do this across, you know, dozens or hundreds of projects at once. So we need to get other people using the software.
Sorry to dominate. Last question is LiDAR scanning. So how did that interact with like your software, or was that just like an as-built BIM model background that was created from the point cloud, and then, you know, you guys did your engineering tool thing, or is there interaction between a LiDAR scan point cloud and your software?
What we found is that the actual maybe you sympathize with this, but the act of collecting the scan is not that hard. So it's only a few minutes per scan, but the difficulty is in doing anything useful with the data. And so we have applied a lot of software engineering to automatically do useful things with the data. And so, for example, HyperBIM will automatically look at the topology of the decks and understand what the deck height variance is, so that we can manufacture the proper stud size for that floor. Our studs telescope and allow and kind of take up plus and minus 3/4 of an inch of deck height slop. But the question is, like, what is that height what is that average height that will work everywhere on the floor? So the software will automatically calculate that. It will automatically, we have automatic hole detection. So to find where the as cast sleeves are in the deck, it will just find them. And so we're not coordinated, you know, for vertical plumbing elements, we're not necessarily coordinating off a model that may or may not be true. We're coordinating off of where those sleeves actually are in the concrete. And sometimes these floors have hundreds of sleeves or thousands even in them. And so the software will just find it all by itself and do a really good job of it. And so that's where we've applied resources.